your little break. I hope also that you are enjoying the whole summit so far. Thank you very much. So now we will start our session, and we will tackle a very interesting component in the entire value chain of Power to X. I believe that from yesterday until now, all you heard about is green hydrogen, off-takers, green hydrogen, electrolyzers, etc., all around green hydrogen. But we are missing a very, very important component, which I believe that is a cornerstone in the success of what we call Power to X economy. And here I am talking about carbon capture. Carbon capture, for those who won't hear, 2 days ago, we organized a science day, and we tackled this subject, and we mentioned clearly that carbon capture use and storage is very important, and it's not easy, and it will require optimization and much effort if we want to develop off-take products at the end. So also regarding technologies, we believe that there is a big challenges regarding technologies. Here I'm talking about direct air capture, for example, and all kind of absorption contexts. So without any other introductions, I will welcome my dear speakers that we will, with them we will have a very interesting discussion. And please, before I introduce them, this is an interaction session. I think that the subject is very important, so we will wait for your questions. We will wait for your comments to make this discussion very, very succeed. So without any further ado, I will call to the floor Mr. Sven GOETHALS. Please join us. Sven is Tractebel's Commercial Director of Hydrogen and Decarbonization, and he spent 30 years of experience in design, engineering, project manager, and sales management for multi-contracts, power and gas projects. Sven, welcome. Thank you. And second, I will call Ms. Carolina Romero. She has a huge career in communication before getting into sustainable development in hydrogen of France. Carolina also, she's a business developer in HDF, and she holds an MBA in particular interest in development of large-scale energy projects. Carolina, welcome. Thank you. And last but not least, I will call to the floor Mr. Yvon BERNARD. And Yvon BERNARD is, thank you, is a business development manager at AXENS, and where he identifies new customers and guides projects from feasibility to maturity. Thank you very much for being here with us. So before we're getting started into the real business, like I can call, I will start with you, Sven, since you were involved in, I imagine, in very plenty projects of decarbonization and hydrogen projects. Can you please share with us quickly what are you doing exactly in Tractebel regarding hydrogen project and decarbonization?
So Tractebel is an engineering company. We are part of the Engie group. You see a little bit a one-pager with information linked to Tractebel. Our history, our bulk of activities come from everything that's linked to energy. When it comes to hydrogen, since almost 10 years we are active on hydrogen. First on small-scale solutions, now on bigger solutions. Sorry. So like most of the companies, we have a lot of pre-feasibility, feasibility studies running, but nevertheless also we have already done some feeds, and we have also some products where we are, we say, accompanying construction as owner's engineer for industrial scale projects. Also, I would like to add, in Morocco we have quite some presence, being active in Morocco already since tens of years, and nowadays working on desalination plants like in Dakhla, in the south of Morocco, also being involved in multiple wind projects, also being involved in quite some infrastructure projects. So, in a nutshell.
Thank you very much for this very insightful introduction. Thank you very much, Sven. Now I will move to Carolina. I believe that Hydrogène de France is playing a major role regarding the development of hydrogen economy and all other components related to this topic. Can you please give us some insights about what you're doing at Hydrogène de France?
Yes, of course. So Hydrogène de France, also known as HDF Energy, is a French company based in Bordeaux, but headquartered in Bordeaux, but having activities worldwide. In Morocco specifically, we have a large-scale e-fuels, so hydrogen and derivative project, which is called NASEM, Sahara Morocco, so also known as NSM. And this is a large-scale project that consists of 2 gigawatts of wind, 1 gigawatt of solar photovoltaics, and of course our own balancing system, the stabilizing system that we are very much developing in a smaller scale elsewhere. And so we want this project to be initiate in the green ammonia production and then move slowly to e-SAF production and e-methanol. It is quite challenging to work on this scale, and we believe that we can do so. We have already very good experience in smaller scale constructions already in Seog, for example, in French Guiana, and we want these ambitions to go even further here in Morocco. So through NASEM, we are exploring many aspects throughout the whole hydrogen, CO2 value chain, and so very happy to share with you some of the things that we have been learning so far.
Thank you very much, and I believe with IRESEN in the framework of project name Mirhi, you explored the opportunities of hydrogen storage via salt caverns, and yesterday it was a dissemination event for those who were interested. Thank you very much, Carolina. Now I will move to Yvon. Since I was with you 2 days ago in the master class regarding carbon capture use and storage, I believe that you're doing a very interesting work. Can you please share with the audience some insights about what you're doing at AXENS?
Thanks, Oussama, and again, thanks for inviting us during this event, as well during the masterclass. So AXENS is a licensing company, so we are developing technologies. We are not building, we are just doing tailor-made design for our customers. So I put on the slide the scheme of e-fuel. So for me today at this table, I will be discussing about CO2 and hydrogen to fuels via the Fischer-Tropsch pathway. So we are historically in oil and gas, so refining and petrochemical, and we are at the edge of the innovation because we are owned by the French Institute of Petroleum, and we are always improving our process as well as our catalysts. So 2 core business, licensing and selling of catalysts. And today you mentioned in your introduction that technology is probably a risk. So of course I'm open to discuss all of this together.
Thank you very much, Yvon. Very interesting. Thank you very much once again. So now I will go back to Sven. I believe that the magic word or the cornerstone word of this entire economy is the value chain. Of course, like green hydrogen, if we take carbon capture or e-fuels as example, it's still the same issue. So we believe that the value chain is divided in many components. So regarding you, what are exactly the main challenges or the main blockers in this value chain? So if we overcome them, we will reach sustainable e-fuel production.
So when we talk about the value chain, I think when we consider, if you speak about green molecules, the name is it itself. We start with green energy production. maybe wind, solar, may also be hydro, may even be geothermal. And what we see in this, let's say already for those components, that yeah, if you speak about really large scale, gigawatt scale wind, solar or geothermal projects, these are things that have never been before. So it's already a huge challenge to set up such a important projects or such a large scale projects. Secondly, we produce electricity, and for sure the energy or the electrical energy needs to be transmitted from the location where the energy will be produced to the location where you will position your electrolyzers. And there again, what we see is that you will need an electrical grid, but definitely in a lot of the, say, regions in MENA, a lot of locations in MENA, where there's abundance of wind and sun, the electrical grid is not necessarily, is sometimes present, but maybe rather weak, or is not present at all. And so this is definitely also a challenge, not proper to e-fuels, but it's definitely a challenge proper to hydrogen, that you need to make sure that your electrical grid may operate in a stable way and that you can observe dynamic variations of milliseconds. Something that was also addressed by the colleagues of Siemens yesterday. When you speak about hydrogen, I think I don't want to fall into repetition, but everybody, okay, we all today, if you look to the projects that are, or the bulk of the projects we have today, we are at 10 megawatt scale. Some projects have already been commissioned, but most of the experience today that we are gaining is rather on the 10 megawatt scale. It's not on a 100 megawatt scale, it's not on the gigawatt scale. So there also we will have the upscaling, and I think there you will fall back on the things that we see in every industry where you go from a rather small scale application to a large scale industrial application. When it comes then to the e-fuels, and there I think Yvon will definitely be able to elaborate much more as a licenser, but a licensing company. We see that, that also the way that we make today e-fuels, carbon capture, for sure carbon capture exists, but today it's mainly for enhanced oil recovery, industrial projects up to 30% carbon capture. This is not what you want if you would go to sustainable e-fuels. So they will need to go to much higher efficiency, never been proven before. So they probably also will need to go to pilot stages and then to industrial scale. And then when it comes to building the e-fuels, it's again the same thing. Solutions are available at lab scale. Today we have also first pilot solutions, but large scale industrial applications, there are some for the time being in the Nordic countries that are under construction, but also there we will need to build and build up an industry and gain experience, learn about integrate lessons learned, return on experience, to come really to a mature and reliable production facility. And perhaps particular to e-fuels, it's also the bunch of e-fuels that we can have. We worked on e-methane projects where rather you have a Sabatier process. You can work on the ammonia with Haber-Bosch. Okay, can be considered as a fuel, sometimes yes, sometimes not. But then you have also the whole e-fuels where you speak about e-methanol. We can speak about jet fuel with also different processes of coming to it. And so what we think, we believe that on hydrogen or electrolyzer itself, we will have scale effects, and probably the industry will gain very quickly in experience. On ammonia, we see that a lot of projects are focusing on ammonia as as a final product. So there probably also will get quite quickly, a little bit later than for the pure hydrogen, but we also get quite quickly experience. When it comes to the e-fuels, there are projects, but the question is, will we have sufficiently the volume in order to come really to repetitive, industrial-scaled projects? So it's definitely, this is also one of the challenges we see.
Thank you very much, Sven. I think you mentioned very important points, like the importance of scaling, this discussion around which e-fuels will be the best, which will be methanol, ammonia, or others. I agree with you. Thank you very much. If we still in the value chain, I believe in value chain we have components like storage and transport. They are very important in terms of cost and efficiency. And here I will address my question to Carolina. What do you believe regarding main challenges and main blockers in this transport and storage thing? And what is going on in the world regarding this question?
Well, so of course, the value chain in relation to CO2 has significant challenges, particularly when we're speaking about giga-scale projects, so huge amounts of hydrogen that are needed. But for example, when we're thinking about SAF, we need 3 times more CO2 than hydrogen, so that is huge. So our ambitions are large, and of course, that adds complexity. In relation to these challenges that you were asking for, so the main ones are, of course, in relation to maritime transport, port infrastructure, infrastructure that is yet not there. For example, in relation to shipping, I mean, ships that are not yet, they are designed and built in order to transport these amounts of CO2. So I believe that developers such as us, so such as HDF, need to be involved actively in working and strengthening this supply chain throughout the project development. In our case, we're working on this aspect, for example, with Terega, which is a gas network utility in southern France. And with them, we are working in relation to a CO2 pipeline in France. They are the main ones, but we are adhering to this project. They are also shareholders in our company, and that is why this is quite strategic in general terms. Another aspect in terms of solutions, how can we do this better, let's say, would be, of course, well, having these discussions also in conjunction with other e-fuel developers in the region. So our project is one of the 40 that Mazen is currently analyzing, and of course, once we advance a bit more with the project, I hope that we will be able to work in collaboration in order to strengthen this value chain, because we all have the same issue, and I think that together we can do this even better. Another solution, if we want to try to avoid partially avoid CO2 supply chain, let's say, is of course producing on site. So one of the solutions for this, well, the solution for this is direct air capture. So that would allow not only to solve the chain in the transport issue, but also strengthen, let's say, and also even improve the balancing of the whole system. For example, in reusing heat that can be used for DAC. We also have the huge advantage of already having cheap energy on site. So all this can, of course, add to having DAC, to our point of view at least, as a very solid technology that will, I mean, it's of course maturing, but that could be, let's say, solving several of the issues that we're dealing with. So really hoping for this to advance. We are looking forward to, of course, helping DAC technologists to get there and to be able to supply that technology for us. We need huge quantities of CO2, so I think that there's no one solution. We will probably need a bit of everything. And so, of course, happy to share more about this later on after the panel with whoever is interested.
Thank you very much, Caroline. I agree with you. And if you may, I would add also the point of regulation and policies, since in carbon capture we have capture, use, and storage, and there is a challenge regarding how to, for each and single one of them, we have regulations, specific regulation, and we have some policies, and the idea of gathering all of them to make the entire value chain succeed is also a challenge. But nevertheless, I agree with you about what you said. Thank you very much. I will go to Yvon. I believe that, of course, you are deeply involved in all kinds of CCUS projects and e-fuel production projects. In your perspective, what do you believe regarding the challenges of profitability and efficiency of e-fuels production? What do you think about that?
So I will talk only about what I know, which is CO2 hydrogen to fuel via Fischer-Tropsch. So if we look at production costs, today we are roughly 60-65% of the cost come from utility, so electricity, and 30-35% from the capex. So if we go to the electricity, of course Morocco has a good potential in some regions where you are around 30 euro per megawatt, and in others where you reach 60 euro per megawatt, then for sure you are in competition with some countries like in the Nordics where they have good hydropower. So for sure electricity cost can boost the profitability. Then if we go to the capex, today you have to actually build this plant. We cannot really do revamps or use existing assets for some technologies. So to reduce the capex, you have one way is to use local manpower, because you have a better cost here in Morocco compared to other countries, around 5 to 10%. You can also look at modularization. Here again, you can get, don't quote my words, but maybe 20 to 30% cost reduction. So here you will, of course, boost the profitability. And then after you can look at some other parameters like integration. Today, a lot of the OSBL capex, so outside of the process, you have to actually build steam generation, wastewater treatment, flare, etc. So using some existing assets, like in Morocco, you have some very big energy company or very big company like steel industries, OCP with the phosphate, etc. Here they have necessarily some fatal heat that we can reuse. So this would be beneficial for the carbon capture, but also for the utilization to fuel. Now, if you look at the cost of the money, weighted average cost of capital, discount rates, today you will have to go to the banks and make loans, and this money actually costs a lot today, more in Morocco than in Europe. So a good way to avoid paying lots of money to the banks would be to have someone that gives you a loan, I would say for free or at 0% rates, which can be possible with the government, for example. Today, what we are facing is first of a kind. It's not for the banks because they don't really like it. They don't like risk. So what we need, at least for the first plant, is to have the strong support from the government by taking bank guarantees. Because today the subsidies are good, but when you get actually the money, you have already paid a few years before. So when you get the subsidies, you will give it directly to the banks. So it doesn't really, it helps for sure, it's better than nothing, but it would be better from the scratch to get the money directly from someone that can borrow it for sure and takes the risk with the industrial players. Now, if you look at cost estimation, so we all talk about feasibility studies. We have an idea of the cost which is not accurate, and then we put more money to make a class 5, class 4, class 3 cost estimates. And at the end, we take EPCs. Sven is one of those engineering companies that probably don't have the same knowledge or return on experience that what we get in the oil and gas, for example. So there are lots of contingencies that are added up to the cost of the project that we initially, us as licensor, had estimated. So by doing more projects, for sure, the cost will be more refined and we will have a better idea, and it will be probably easier to take decision and go actually to the final investment decision. So overall, if we look at licensor now, which is our role to innovate and to propose something new with better efficiency and again to boost profitability, integration with existing asset is one. Us, we need also to develop technologies that are more efficient, but it doesn't mean that the process will change drastically. Because I hear many people say, oh, the technology is not ready, we need to wait. In fact, you don't need to wait, you need to actually build the plant, and then we will do improvements. It doesn't mean that you need to decommission the plant and build a new one. We just improve the catalyst, we just improve some efficiency of equipment, and that's the life of the, so I take again the parallel with oil and gas, but that's the life of refineries. We have built plants, small scale, we have improved them over the time, and then bigger plants came, and then after 30, 40 years, yes, the small scale plant is not profitable as the biggest one, but the smallest one has already made lots of money, lots of cash. And I think we need to take the parallel with this, I mean, this history of oil and gas or other type of industries, and say, okay, let's go now, we have everything in hands. Okay, we don't have the co-electrolysis, we don't have the solid oxide, which is TRL9, but you have PEM, you have alkaline, so you can go. Carbon capture, it's something, okay, it's well known in the industry. We have captured CO2 with amine for the last 50 years. So let's go. For Fischer-Tropsch, it's a technology used by the Germans 50 years ago. So it exists, there are already some plants available. So all of this, put them together, yes, there is a technology risk, and that's true, but we can always start 100 megawatt, 200 megawatts. We get return, okay, which is probably lower than what we expect in some other industries, but while ramping up, learning curves, and for sure it will be more and more profitable. Of course, with a stable regulation, etc., but I think we have all talked about this for the last day, so I will not talk about regulation.
Thank you very much, Yvon. I agree with you, and if I catch some points in your intervention, you mentioned local manpower, which is very important to enhance also the development of such economies. Also, you talked about the risk that and the bankability of these kinds of projects, and this leads us to make more efforts to make these technologies more mature, because I believe that banks would not like to take risks with technologies with less maturity. And thank you very much. If I go back to Sven, I believe personally that partnership and collaboration may enhance CCUS and e-fuels economy. What do you think regarding this matter, and what do you think what needs to be done to enhance partnership and collaboration to make this economy more suitable?
It's clear that finally we are all, when we speak about hydrogen, when we speak about e-fuels, we are all at the beginning. Some are a little bit more advanced than the others, but if you look at it on a global scale, we are all at the beginning. And it's clear that events like this one, also working groups where people exchange their return of experience, exchange what are the problems that they live, what are the solutions that they brought in, are essential in order to avoid that errors or mistakes or improvements that are found, that finally the whole industry can benefit from it. Quite often when we speak with clients, we also share with them some of our return of experience, just to ensure that even if we are not involved in the project, that some of the things that are evident as we lift some of those problems, that at least they can help to avoid it, and that they come to a successful project. Because I think this is what we need in the industry, to have projects that are successful. When then, if you look to and if you look a little bit to hydrogen, You see guys like us coming rather from the electrical power sector. You see guys like Yvon rather coming from the oil and gas sector. We also see people coming from the chemical sector. Everybody has a little bit his own background, but we believe that that if we want really to go ahead, we should really also take into account, the experience, the best practices from each of these industries. Listen and learn to each other. Listen to each other, learn from each other, and then see how together we can go ahead. Also, if you look then to the and this I explained a little bit in the value chain, you have really a rich variety of people coming from different origins. You have also quite a complexity of projects, because you will speak with PV manufacturers, you will speak with wind OEMs, you will speak with electrolyzer OEMs, you will speak with the licenses, and you cannot. We all need each other in order to go ahead on a project. So that's a little bit on a technological global scale that we think, what we should do in order to proceed. Secondly, we also, contrary to, and then I fall back on our background from electricity sector, electricity is finally something that is handled on a regional or a local level. You produce local electricity, you have some transmission lines, and use it locally. On the contrary, with hydrogen and all the e-fuels, all e-molecules, it's something global. And so we also need to make sure that let's say that this collaboration, or that's at least at a certain moment an alignment on the rules and regulations that everybody applies, so that there's a kind of equal level playing field. Finally, all of these projects, it will be some of the products will be used, some of the molecules will be used locally, some of the molecules will be exported, but in the end, everything will be, there's a big footprint, local footprint, and so we may definitely not forget that these projects will also be massive, and so we will definitely also need to involve the local workforce, the local expertise, in order to have the public acceptance, but also be in a realistic way, be capable of realizing, constructing these projects, but also those projects need to be operated during 30, 40 years, also to be capable of maintaining them, and be sure that the projects can also then realize the cash and generate the cash needed in order to make the business plan fit. So it's really a collaboration. I only wanted to say, highlight 3 examples, but I think the longer you would discuss on it, the more you would see that collaborations, partnerships are necessary, because it's probably projects that if you look at the chemical sector on its own, if you look at the electricity sector on its own, and I think even that for some of the, say, projects in oil and gas, these are of a level that go far beyond what each of us individually did.
Thank you very much, Sven. If I would like to highlight one thing you just said is learning from each other, help each other, because I believe that none of us has the entire knowledge regarding the entire value chain of CCUS and e-fuels, and this cooperation, international cooperation, is very important. It's very mandatory if we want to make this a success. Thank you very much. If I earlier, Yvon mentioned the question of cost, and here I will ask you, Carolina, regarding cost. What do you think we should need to do if we want to reduce significantly the costs of production of e-fuels, from your perspective?
Well, of course, as project developers, we have the chance to analyze, let's say, the whole business plan with every single part containing, of the project. So we have the chance of having this whole view, and we know that in order to get to competitive e-fuels, we need to optimize every single bit throughout the value chain, throughout the project development, try to shorten also as much as possible the time in which we develop these projects and optimize the whole system, let's say. If we go to the points that are much more sensitive, of course, as we all know, renewable electricity as an input for hydrogen takes up more than 60% of competitivity, let's say. So the good thing is that, well, in Morocco and particularly in the southern region where we are working with the Nazem project, all this region has very good wind, very good solar potential, and of course that already makes us check that box. So already competitive renewable energy, we got it. Then, of course, there's a need to have the balance of plant adjusted and optimized. So at HDF, we have the chance to already be quite advanced in this topic. We have other systems that are being built and being developed worldwide. So with the first construction in Seog, but with other projects in very advanced stages of development, even a small version in our factory in Bordeaux. So that gives us quite a good know-how in how to optimize that balance of plant. Of course, as I was mentioning before, we need huge amounts of CO2. So to get that cheap or cheaper CO2, we need to adjust it as much as possible, choose the right technologies, and also, well, also get to the quantities that we seek for, of course. One of the possibilities, you were mentioning collaboration as a possibility, I mean, as a necessity. Of course, working in conjunction and as a pool of developers will be needed if we want to get that supply chain and to get that as a competitive supply chain. Then, of course, I believe that another part that is also important is taking an active role in allowing that supply chain to be a reality at the time that we want. So we want to try to we want to produce by 2029, 2030, and to get there, we need to be quite active in helping the technologists to get there. Ourselves at HDF Energy, we have a manufacturing activity as well on fuel cells. And so we have been able to reach that industrial scale. And we want to help also CO2 capture technologies to get there as well, because not only because we need it, but because the industry does as well. So working collaboratively, not only with the developers, but also with those that are developing the technologies is also important. So I would say that having cheap CO2, which is quite easy, let's say, here in Morocco, then having the good balance of plant and strengthening collaboration within the CO2 supply chain, I believe that is essential already and the base for optimizing the final business plan and getting as competitive fuels as possible. We know that fossil fuels are already quite competitive, and we have a huge challenge ahead of us. So working together with all the sector in doing that a reality.
Thank you very much, Carolina. The availability of CO2 is something, and it's very important. It controls the CO2 cost at the end, especially sustainable CO2, which is it's another story that needs another session. And also, you mentioned the thing about the technologies. I agree, I fully agree with you. The more technologies are mature with collaboration with help, the more the less the cost is, which is very clear, and I agree with you. Thank you very much. If I stay with this cost history, Yvon, I believe in AXENS you've been fully implicated with too many kinds of industries across the European countries. In your perspective, what is your philosophy with industrial partners to convince them with this question of cost efficiency and profitability, so they can use or lean on e-fuels production?
Okay, so first of all, let's go back to profitability. There are two things, the cost and whether there is a customer ready to pay for this actual product. So today, the regulation is here to push or to oblige the airlines or the maritime sector or whatever sector, plastic sector, to include more and more renewable materials. So today, if you have a better cost of production and the customer is ready to pay more, you will get better return, that's for sure. But profitability, it's made more by the regulation. Today, if the ETS in Europe or if any kind of regulation sets a CO2 price at a higher cost, then I don't need to convince anyone because business plans are crystal clear, they will make money. Today, the fluctuation of the CO2 makes one day a project profitable, the other day not profitable. And when we say, okay, the regulation needs to be clearer, I think setting a target and a threshold will make everything more profitable and push industrial players and everything around the value chain to actually make projects. Now, what we can do on profitability, that's only two questions I had today. So, of course, integration between carbon capture and utilization is one. But you can, depending on the context, you don't have the capabilities to do that. Sometimes the CO2 source is far, sometimes let's say the refinery part is a bit further away. So it's difficult to integrate. And what we saw on the masterclass is that amine carbon capture use steam, and we produce steam in Fischer-Tropsch, so there is a clear integration possible to reduce the cost of the production. I think I answered your question. And how we can support our customers. So by doing different projects everywhere in the world, we have different hypotheses and different contexts and different challenges. So today, by doing all those feasibility study stages, plus the knowledge we have in our historical background as a licensor to tailor-made to our customers, then for sure we have more options how to integrate with existing assets. What's the cost of CO2? Do we need storage? Is the technology flexible? So today we have everything in hand to be able to have a clearer picture and to make business plans. And then after that, if it's still not profitable, then we need to think about other solutions, different place, modularization, different EPC, different skills, etc.
Thank you very much, Yvon. Now I will give the floor to the dear audience. If there is any questions, please, our speakers want a question, so don't be shy. It's a very important topic, and we have a very distinguished speakers with us, with a lot of experience. Please ask the questions. Anyone? Come on. At least one. Are you sure? Okay. Before I close this session, if I may ask each and every one of you, if in 1 minute, if you can share with us a key message, what we have to keep in mind by the end of this session. I will start with you, Sven.
Well, my key message would be that for the time being and presently, when I look to let's say, the number of projects that are concretized today, where FIDs are taken, it's clearly not the gigawatt scale projects of which everybody talked in the industry 3-4 years ago, even 2 years ago. But nevertheless, we see that projects of the size of 10 megawatt, 20 megawatt are coming up. In some specific cases, we find or we see that there is a special matching between where projects of higher scale are concretized. So we believe that that we are now on the slope of ramping up, waiting, and this is always difficult, waiting on the moment when it will really accelerate. And this then linking to the e-fuel session, once we see also, and this has been in the European funding, there were also some projects in the Nordic countries who received funding on e-fuels projects. And so it's clear that whenever, let's say the size of the hydrogen projects will increase, we will also see the e-fuels projects concretizing.
Thank you very much, Sven. Carolina?
I would say that as a key message would be like things don't happen just by chance or just because they just happen. I mean, we need to take active roles in making these ambitions a reality. So each and every one of us is in different parts of this whole system and this ecosystem that is quite new, developing. But if we want regulation to be oriented towards having a higher cost of carbon, we need to be active in engaging the discussions that are good for this to happen, engage in discussions with the ones that are developing other parts of the value chain in order to help them also get there as well in the time that we need as well. So I think that this kind of event already helps us initiate these discussions. We need to strengthen these links between us and strengthen and deepen these conversations and take an active role, because things don't just happen. We need to make them happen. So big ambitions, big challenges, but also a big responsibility.
Hopefully, thank you. Yvon?
I want to send a positive message. So to make a project, we need CO2, electricity, hydrogen, technology, and someone to finance it, and someone to buy the final products. So finding the CO2 is possible. Sources are identified. The regulation exists. It's not perfect, but it exists. Electricity, I think capacities are building up on solar panel, PVs, and nuclear for some countries. So we will find electricity in sufficient quantity to make actually the first projects. So 200 megawatt, 150 megawatt, 250 megawatts. That's a scale that is sufficient to have a profitable project. Land, I think we've talked about Mazen here. So the land is available thanks to the Kingdom of Morocco. So that's a good news. Technology, so that's my part. I want to share that technology risk is mitigated, and we are open to show what we have done to develop the technology to you, to the customers, to the final user of the staff, and also, of course, to the financial bodies. And now on the financial part, that's more on the project developer business, but we see that there are some funds that are ready to invest, so to share the risk. So that's a big job from the business developer side to actually finance those projects. And of course, on the offtake side, as I said, they are more or less obliged to buy it. They also want to show that they are doing something for the environment. So the whole value chain exists. It's not so complex to put them all together. At the end, everybody has to share the risk. Off-taker by probably buying at a higher cost. The business developer by, of course, putting lots of money, but at the end, expecting good returns. And then things will move forward, and some project will be decided.
Thank you very much, Yvon. And once again, thank you, guys, for this great session. I think we had a great session. We shed lights on many aspects and many challenges regarding CCUS and e-fuels economy and how we can overcome them. Thank you very much again. Thank you very much for the audience, even you were shy. But thank you for your time. And with this, I close the session. Thank you very much.